Hello, I am not feeling very well today, so as you probably don't want to catch the flu, I'll be staying home. I do want to talk to you about the elevator problem here that I had you think about. So, to get oriented, I'd like you to start thinking about the force diagram. You've got this little mass which is hanging on a hook, and gravity is pointing downward, it's pulling it downward, and the force of gravity is a perfect constant. It never changes no matter what. And then you've got a tension force pointing up. And that tension force is what we actually measure. And that can change. So here's the graph that we got in class, or a graph we got in some class. You can see before the elevator starts that gravity and tension are just equal to each other because it's not moving anywhere. And then we get this little bump right here. We also get a little bit of noise. And then it's flat again. And then we get this little downward bump where the tension force gets smaller. So at the beginning of our elevator ride, the tension force is bigger than usual. And at the end, it's smaller than usual. And then here we have come to a stop. So why is it doing this? Well, gravity and tension are fighting each other. And when that little mass is just sitting on the floor, minding its own business, the elevator's not doing anything, it's perfectly stationary, gravity and tension fight each other and nobody wins. It is a perfect tie and there is no acceleration whatsoever. But when the elevator starts moving upwards, well, it's got to get that mass moving upwards. It's got to accelerate it upwards. And the only way it can do that is if the tension force overpowers the gravity. That's how you get this thing to accelerate up. And that's exactly what happens right here. The tension force is greater than the force of gravity, so there's acceleration upwards. Now, once the thing is going at a constant velocity, remember Newton's first law, an object in motion tends to remain in motion, the forces can be perfectly balanced and it will just keep on trucking at a constant velocity. And that's exactly what happens. So our elevator is moving up at a constant velocity, there's no acceleration, so gravity and tension go back to being in a perfect tie. Now, once the elevator reaches the second story, well, now it's got to slow down to a stop. And since it's moving upwards, it has to accelerate downwards. And the way to make it accelerate downwards is your gravity force now has to win the tug of war. So the tension force has to get a little bit smaller. And that's exactly what happens. Tension force is a little bit smaller right here. Okay, I have some in-class problems that I'd like you to work on. They are on the LMS. Good luck.